What is the universe made of? Have you ever looked up at the night sky and felt like you were standing on the edge of something enormous? Like there's something right in front of you, something massive and powerful and everywhere, but you just can't see it. That's not a metaphor. That's literally what it's like to be human. Right now, at this very moment, you are surrounded by things you cannot see, cannot touch, cannot explain. They are in the air you breathe, the space between your fingers, the empty corners of the room you're sitting in. They make up most of the universe, and we have no idea what they are. Everything you've ever seen, everything you've ever touched, everything you've ever experienced, every star, every planet, every person, every breath of air, every grain of sand makes up less than 5% of the universe. 95% of everything that exists is completely unknown to us. We are living in an invisible cosmos. Let me tell you how we discovered this, and why it's the most humbling, thrilling, and terrifying story in all of science. The discovery that changed everything. It started with a Swiss astronomer named Fritz Zwicky. He was brilliant, eccentric, the kind of scientist who wore a lab coat everywhere, and had ideas that made his colleagues think he was insane. In the 1930s, he was looking at a cluster of galaxies called the Coma Cluster. He measured how fast the galaxies were moving, and he found something that made no sense. The galaxies were moving way too fast, so fast that they should have flown off into space. The cluster should have torn itself apart, but it didn't. Something was holding it together, something invisible, something massive. Zwicky calculated that there had to be about 400 times more mass in the cluster than what he could see. He called it dark matter. Nobody believed him. For decades, his discovery was ignored. Scientists thought he made a mistake. They thought his measurements were off. They thought he was just being dramatic. The scientific community moved on, convinced that Zwicky had simply been wrong. His work was filed away, forgotten, a curiosity from a brilliant but flawed mind. Then, in the 1970s, Vera Rubin proved him right. She was measuring how fast stars orbit the center of galaxies. According to physics, stars on the outer edges should move slower than stars near the center. That's basic gravity. Planets farther from the sun move slower. It's the law. It's what Newton told us centuries ago. It's what Kepler observed in the heavens. It's one of the most fundamental principles in all of physics. But Rubin found the opposite. The stars on the outer edges were moving just as fast as the stars near the center. They were zipping around at speeds that should have flung them into space. They should have been torn away from their galaxies like rocks from a slingshot. But they weren't flying away. Something was holding them there. Something invisible. Rubin's discovery was the smoking gun. Dark matter was real. Every galaxy we see is surrounded by an invisible cloud of mass that keeps it from flying apart. It's like a cosmic spider web, threading through the universe, holding everything together. Without it, galaxies would literally disintegrate. The stars would fly off into the void, and the beautiful spiral structures we see in the night sky would vanish. But what was this invisible stuff? We still don't know. The hunt for the invisible. Scientists went looking for dark matter in every way they could think of. They looked for failed stars called brown dwarfs. These are objects too small to ignite nuclear fusion, but large enough to have significant mass. They looked for black holes left over from the early universe. They looked for clouds of gas too cold to see with our telescopes. They even looked for hypothetical particles that only interact through gravity. Particles that were predicted by theories, but never observed. They found nothing. Here's the thing about dark matter. It doesn't emit light. It doesn't absorb light. It doesn't reflect light. It's completely invisible to every instrument we've ever built, from the smallest optical telescopes to the most powerful radio arrays. The only way we know it exists is through its gravitational effects. It bends light as it passes by, a phenomenon called gravitational lensing. It shapes the structure of the universe, creating the cosmic web of galaxies and voids that we observe. It influences the formation of galaxies, providing the gravitational seeds that allow them to grow. Without dark matter, the universe would look completely different. There would be fewer galaxies. They would be smaller. The cosmos would be a far emptier place. But beyond that, we don't know. Here's the wildest part. Dark matter passes right through normal matter like it's not even there. Right now, billions of dark matter particles are streaming through your body. They're passing through the walls of your house, through the floor, through your skin, through your organs, and you can't feel them because they don't interact with the atoms in your body. They are like ghosts, completely invisible, completely untouchable, and all around us. If you could see dark matter, the night sky would look completely different. It wouldn't be a dark void with tiny points of light. It would be a glowing, swirling sea of invisible mass, threading through every galaxy, stretching across the cosmos. It would be breathtaking. It would be terrifying. It would be everywhere. Dark matter outnumbers normal matter by 5 to 1. It makes up about 27% of the universe. We know it's there. We can measure its effects. We can map its distribution across the cosmos. We can see how it bends light and shapes galaxies. But we can't see it. We can't touch it. We can't explain it. The breaking of physics. Now we get to the part that makes physicists wake up in a cold sweat at 3 a.m. Dark energy. We've known for a century that the universe is expanding. That was one of the great discoveries of the 20th century. Edwin Hubble, after whom the Hubble Space Telescope is named, showed that the galaxies are all moving away from each other. The universe is stretching, like a balloon being inflated. And for most of that time, everyone assumed the expansion was slowing down. Gravity should be pulling everything back together. That's basic physics. That's what we teach in school. That's what Newton told us. That's what Einstein's equations predict. The universe should be decelerating, gradually slowing down until gravity eventually brings everything to a halt, and then pulls it all back together in a big crunch. In the late 1990s, two teams of astronomers decided to measure exactly how much the expansion was slowing down. They used a special type of exploding star called a Type Ia supernova. These explosions have a very specific brightness, which makes them perfect for measuring cosmic distances. Astronomers call them standard candles. When you see one, you know exactly how bright it is. You can measure how bright it appears, and from that, you can calculate how far away it is. It's a remarkably clever technique, and it revolutionized our understanding of the universe. They expected to find that the expansion was slowing down. They expected to measure the deceleration, to confirm what everyone already believed. It was supposed to be a routine measurement, a confirmation of established theory. Instead, they found the opposite. The expansion wasn't slowing down. It was speeding up. The universe is expanding faster now than it was billions of years ago. Something is pushing it apart. Something with an anti-gravity effect. Something so powerful that it's overcome the gravity of all the matter in the cosmos. Something so strong that it's accelerating the expansion of the entire universe. Something we've never seen before. They called it dark energy. It was the most unexpected discovery in decades. It shattered everything we thought we knew about the universe. It was like throwing a ball in the air and watching it accelerate upward instead of falling back down. It made no sense. It contradicted everything we understood about physics, and it forced us to confront the fact that we don't know nearly as much as we thought we did. The most powerful force in the universe, dark energy, makes up about 68% of the universe. That's more than dark matter and normal matter combined. It's the most powerful force in existence. It's the dominant influence on the evolution of the cosmos. It's the reason the universe is expanding the way it is. It's the reason the night sky will eventually go dark, and we have absolutely no idea what it is. We know some things about it. We know it's constant, at least as far as we can tell. It doesn't change over time. Even as the universe expands, we know it's extremely weak on small scales. You couldn't detect it in a lab. It only becomes noticeable across billions of light years. We know it acts as a kind of negative pressure, pushing space itself apart. As space expands, more space is created, which creates more dark energy, which causes the expansion to accelerate even faster. It's a runaway cosmic explosion that's been happening for billions of years. And it's not slowing down. It's getting faster. The leading candidate for dark energy is something called the cosmological constant. It was originally proposed by Albert Einstein in 1917, and he later called it his biggest mistake. When he first developed his theory of general relativity, he realized that his equations predicted a universe that was either expanding or contracting. That didn't fit with the prevailing view of the time, which was that the universe was static and eternal. So Einstein added a fudge factor to his equations, a constant that would counteract gravity and keep the universe stable. It was a brilliant idea, but it was also a cheat. It wasn't based on evidence. It was just an attempt to make the math work. When Hubble discovered that the universe was expanding, Einstein abandoned the cosmological constant. He called it his biggest mistake. He said he should have trusted his equations. He should have predicted the expansion of the universe before it was observed. But in the late 1990s, the cosmologists who discovered dark energy realized that the cosmological constant was exactly what they needed. It could explain the accelerating expansion of the universe perfectly. It was a kind of energy inherent in empty space itself, and it made the math work. It was the same idea Einstein had proposed almost a century earlier. But here's the problem. When physicists try to calculate how much vacuum energy should exist, based on our understanding of quantum mechanics, the number they get is 10^120 times larger than what we actually observe. That's a 1 followed by 120 zeros. A number so enormous, it's basically incomprehensible. It's larger than the number of atoms in the observable universe. It's larger than anything we can possibly imagine. The discrepancy is the worst prediction in the history of physics. It's not just wrong. It's off by a factor that is larger than the entire universe itself. So not only do we not know what dark energy is, we also have no idea why it's so weak. It's one of the biggest puzzles in all of physics. It's a crisis in our understanding of the cosmos, and it's a crisis that we don't know how to resolve. The end of everything. This is where it gets dark, not just metaphorically, actually dark, the darkest thing you can imagine. If dark energy continues to push the universe apart, eventually all the galaxies will move so far away that they disappear from view. In about 1 trillion years, no galaxy outside our own will be visible from. The night sky will be completely empty. No stars, no planets, no galaxies, just darkness. The universe will become a cold, dark, desolate wasteland where nothing exists and nothing ever will again. The stars will burn out. The black holes will evaporate. The atoms themselves will decay into nothing. This is the fate we're facing, and it's all because of dark energy. It's the most powerful force in the universe, and it's going to tear everything apart. But here's the thing. We don't know if this is definitely what's going to happen, because we don't know what dark energy is. For all we know, it could change. It could get stronger, accelerating the expansion so fast that the universe is torn apart in a big rip. In a big rip scenario, the expansion becomes so powerful that it overcomes the fundamental forces that hold matter together. Atoms are torn apart. Molecules are destroyed. Even space-time itself is ripped to shreds. Everything ends in a single, cataclysmic moment. It could get weaker, allowing gravity to eventually pull everything back together in a big crunch. In a big crunch, the expansion slows down, stops, and reverses. All the matter in the universe collapses back into a single point, a singularity like the one that existed at the moment of the Big Bang. The universe ends in a fiery collision of everything against everything else. It could even be part of a cycle where the universe expands and contracts forever. In this scenario, the universe goes through endless cycles of expansion and contraction. Each cycle begins with a big bang and ends with a big crunch, and then it starts all over again. It's a cosmic heartbeat, a rhythm that has been playing for eternity and will continue playing forever. The problem is, we don't even know how to start figuring it out. We don't have a theory that explains dark energy. We don't have a theory that explains dark matter. We have observations. We have evidence, but we don't have an explanation. The cosmic pie. So let's put it all together. This is what the universe is made of. About 5% is ordinary matter. Everything you've ever seen, touched, or experienced. Every star, every planet, every person, every piece of dust, all the atoms in your body, all the atoms in the earth, all the atoms in the sun, all the atoms in the entire galaxy. It's a rounding error, a cosmic afterthought. About 27% is dark matter, an invisible substance that holds galaxies together. We know it exists, but we can't see it, touch it, or explain it. It's everywhere. It's all around us. It's streaming through your body right now, and we don't know what it is. About 68% is dark energy, a mysterious anti-gravity force that's pushing the universe apart faster and faster. We have even less idea what this is than dark matter. It's the most powerful force in the cosmos. It's the dominant influence on the evolution of the universe, and it's completely unknown to us. That means 95% of the universe is completely unknown to us. The search continues. So what are we doing about this ignorance? We're searching. We're searching harder than we've ever searched for anything before. We're building detectors deep underground. Massive tanks filled with liquid xenon, waiting for a dark matter particle to bump into an atomic nucleus. These detectors are buried miles beneath the Earth's surface, shielded from the cosmic radiation that would otherwise drown out the signal. They are incredibly sensitive, able to detect the faintest whisper of a particle interaction, and they've been running for years, waiting for a sign. So far, they've found nothing. We're building giant particle accelerators, like the Large Hadron Collider at CERN. We're smashing protons together at nearly the speed of light, creating conditions that haven't existed since the Big Bang itself. We're hoping to create dark matter in the lab. We're hoping to see it. We're hoping to understand it. So far, we haven't found anything, but we keep looking. We're launching space telescopes like Euclid and the James Webb Space Telescope. We're mapping the distribution of galaxies across cosmic time. We're looking for subtle distortions in the light from distant objects. We're trying to understand how dark energy has changed over the history of the universe. We're hoping to see something that will give us a clue, something that will break the mystery wide open. We're even looking for gravitational waves, ripples in the fabric of spacetime itself. When massive objects merge, they create ripples that travel across the universe at the speed of light. Some physicists think that merging dark matter objects could produce gravitational wave signals that we could detect with observatories like LIGO. It's a long shot, but we're trying, and every year, we learn a little bit more. We rule out another candidate for dark matter. We measure dark energy a little more precisely. We get a little closer to understanding the 95% of the universe that we currently can't see, but we still don't have answers. The mystery endures. The humbling truth. Let that sink in for a moment. We have sent rovers to Mars. We have built telescopes that can see billions of light years into space. We have smashed atoms together at nearly the speed of light. We have developed theories so complex that only a handful of people in the world can understand them. And after all of that, we can only explain 5% of what's out there. 5%. Isn't that humbling? Isn't that beautiful? Because this isn't the end of the story. This is the beginning. This is the moment where we realize how much we don't know. And that realization, it's the most exciting thing in the world. There's something beautiful about being a species that is only just beginning to understand the cosmos. We're like children looking up at the stars for the first time, filled with wonder and curiosity, and the burning desire to know what's out there. We're explorers. We're pioneers. We're standing on the edge of the unknown, peering into the darkness, wondering what's out there. And there's something beautiful about the fact that the universe is still hiding secrets from us, that it's not giving up its mysteries easily, that we have to work for every discovery, that we have to struggle and fail and try again, that we have to build bigger machines and launch more telescopes and ask harder questions, because that's what makes it meaningful. That's what makes it worthwhile. The struggle, the pursuit, the endless, never-ending quest to understand the universe we live in. The real answer. So what is the universe made of? The real answer, the honest answer, the one that keeps astronomers up at night and makes physicists question everything they thought they knew. The universe is made of mystery. It's made of the things we don't know, the things we can't see, the things we can barely even imagine. It's made of dark matter and dark energy, and everything we haven't discovered yet. It's made of the questions we haven't asked and the answers we haven't found. It's made of wonder and curiosity, and the burning desire to know what's out there. The universe is mostly unknown, and that is absolutely thrilling, because it means the best discoveries are still out there, that the biggest breakthroughs are yet to come, that the greatest mysteries are waiting for someone to solve them. Maybe that someone is you, maybe not, but the questions will keep coming, the exploration will keep happening, and someday, maybe someday soon, we'll finally figure out what the universe is really made of. Until then, we have the joy of wondering, the thrill of not knowing, the privilege of being alive at a time when the biggest questions are still unanswered, the privilege of being part of a generation that might finally crack the greatest mystery in all of science. And that, I think, is a beautiful thing, the final perspective. So the next time you look up at the night sky, remember what you're really seeing, a universe that is mostly invisible, a universe that we barely understand, a universe that is mostly dark matter and dark energy, and everything we haven't discovered yet, a universe that is more mystery than matter, more unknown than known, more darkness than light. Remember that the atoms in your body were forged in the hearts of stars. Remember that you are made of star stuff. But also remember that the universe is made of stuff that is far stranger and far more mysterious than anything you've ever imagined. Stuff that we can't see, stuff that we can't touch, stuff that we can't explain. We are tiny. We are insignificant. We are living on a speck of dust in an infinite cosmos that is mostly unknown to us. We are less than a rounding error, less than a cosmic accident. We are almost nothing, but we are also the ones who ask questions, the ones who look up at the stars and wonder. the ones who refuse to accept ignorance as an answer, the ones who keep searching, keep probing, keep pushing the boundaries of what's possible. We are the universe observing itself. We are the cosmos becoming aware of its own existence. We are the ones who carry the torch of curiosity into the unknown. And that, I think, is the most beautiful thing of all, because the universe might be mostly made of mystery, but we are the ones who are trying to solve it. And that makes us part of something bigger, something more important than any of us could ever imagine. Something that connects us to every human who has ever lived and every human who will ever live. So keep looking up, keep asking questions, keep wondering what the universe is made of. Because someday, maybe soon, we'll find the answer. And when we do, the universe will never look the same again. The unfinished story. We are living in a remarkable time. A time of discovery. A time of revolution. A time when the biggest questions are still unanswered and the greatest discoveries are still waiting to be made. We don't know what dark matter is. We don't know what dark energy is. We don't know what 95% of the universe is made of. And that's okay. That's the point. Because science isn't about having all the answers. It's about asking the right questions. It's about refusing to accept ignorance. It's about pushing forward, step by step, discovery by discovery, until we finally understand. And we will. Someday, maybe not in our lifetimes, maybe not in our children's lifetimes, but someday we will understand. We will look back at this moment, at this time when we didn't know, and we will marvel at how far we've come. We will remember the days when the universe was mostly unknown, and we will be grateful that we had the courage to ask the questions. So here's to the mysteries. Here's to the unknown. Here's to the 95% of the universe we don't understand. May they haunt us. May they drive us. May they inspire us to keep looking, keep asking, keep wondering, because that's what makes us human. The relentless pursuit of understanding, the refusal to accept ignorance, the burning desire to know what's out there. That's the story of what the universe is made of, and it's still being written, right now, by people just like you.